All right, so today is one of 2-day lessons. So day one is multiplying rational expressions. So our essential question is, how do I simplify and multiply rational expressions?
And a rational expression is a quotient
Which means dividing,
of
fraction.
a fraction of two polynomials, right? And here's some examples of rational expressions.
Okay.
When identifying, there's a big caution. We better read over that, Ms.
Okay.
Boyd. When identifying values for which a rational expression is undefined, identify the values of the variable that make the original denominator, what's denominator
Bottom.
mean? Bottom equal to 0. Because
so like up here, -2 would
Right.
make that 0.
So
Okay.
maybe let's write a fraction. Let's just write
Sure.
2 over 0 for the fun of it. 2 over 0. That is undefined. So what we're saying is, if you end up with 0 in your denominator, that is always undefined.
Right.
It is not possible.
Right.
Miss Boyd's just going to finish writing that, and then I'll scroll down.
Okay.
So number 1, simplify.
All right.
Identify any x values for which the expression is undefined. So let's simplify first, Miss Boyd. Let's deal with the 10 and the 6
Okay.
first. Let's ignore the x to the 8th. Let's
Right.
ignore the x to the 4th. How do you simplify a fraction?
You can divide them both by 2.
Right. And when we do that, we get 5 over.
3.
Now, notice, we're dividing bases that are the same. They both
Oh,
have.
boy.
We're not sure what Miss Boyd is doing.
I tried to
She's
circle it.
trying to
It's
circle it, but it's kind of
It's
turned
fine.
into
It's
a
fine.
disaster.
Okay. We
Okay.
have the bases the same,
Yes.
and we have a division bar that looks like a minus sign.
Right.
So we subtract our exponents.
8 minus
So-
4 is.
I'm actually getting rid of this big line.
All right then.
And 8 minus 4 is 4, so we have x to the 4th.
Correct. Exactly. And I know she got rid of that long line,
Oh,
and that's fine.
Technically, it can go on top.
It can, if you're ever uncertain, maybe write 2 different things.
Right.
Just so I know they get confused. That is correct too.
Got it.
Either one is correct. Just
Okay.
don't put the x to the 4th in the bottom.
Right.
So that's why I kind of like if you can circle.
Yeah,
I
all right,
like
all right.
the blue. I'm sorry.
That's
I'm
okay.
kind of picky because then if you put it in the middle, I'm like, okay,
Right.
where are they putting
Okay.
it? All right.
Very good.
Now, we have to identify the x values for which the expression is undefined. Now, notice our final answer.
Mhm.
There is no x in the denominator.
No.
But you're looking back at your original problem.
Oh. so
Because
this one,
if x is 0, guess what?
x can't be 0.
Right. That's it.
All right.
Mm-hmm. Okay,
Great.
you're done.
That's easy.
Example 2. Simplify. Oh boy, guess what we're back to, Miss Boyd?
We're gonna
F-A-C.
factoring.
T-O-R.
Oh, boy.
Factor. Factor. Yay, factor.
All right.
Okay.
So anyways, we asked ourselves, what 2 numbers can we multiply to get a -2 but add to get a +1?
Right.
That would be a +2
And a negative 1. And you need an x
Yep.
and an x. Nice job.
Great. Same thing on the bottom. What 2 numbers do we multiply to get a -3 but add to get a +2?
That would be
And that'd be a
positive 3
and a
and a negative
2. Oh, -1.
Yeah.
Yes. Oh boy.
My cheer.
right.
My cheer
She
just got the
threw
best
me
of
all
her. She's
off.
really struggling right now.
All right. So now we're looking, and we can cancel these out.
Oh, I
They're
love, that's
exactly
my
the same.
favorite part of these problems. I love
Cancel.
crossing stuff out.
Okay.
So let's write our final answer now.
Okay. Our final answer is x plus 2 over x plus 3.
Circle. Now, okay, look at the final answer, right?
Mhm.
We never look at the final answer when we're determining what x values make the expression undefined. You
Okay.
go back to not the original here, because that's
Oh,
too hard.
This one.
Yes, and
Okay.
even though you crossed off x minus 1,
Oh,
you
we have to
still
use it.
you
Okay.
still have to use that.
So x can't be
Negative 3 and
or +1.
1. So basically the x values we're coming up with are the x values that could make the denominator 0. If you're
Before we simplify.
right.
Okay.
And if you're ever confused how we found that, set x plus 3 equal to 0.
Mhm.
You're going to get x is -3.
Got it.
Okay?
Okay.
All right. Example 2, I think we should save.
Okay.
Or did I say 2? Example 3,
Yeah,
I think we
this
should
next
save.
one we're
Yeah.
gonna save.
Ooh. Ooh.
Yeah.
What do you think? Ooh. I wonder, oh man, can I just check something
Sure.
out? Oh, Yikes. There's a
It's never good when
lot.
she
There's
says, "Ooh."
there's a lot of problems here.
All right,
I
let's pick
honestly,
one.
this one is a class one because that's
All
the
right.
hard factoring.
All right.
So should we save 3 and 4
Okay.
and go down to 5?
Sure.
Okay. Here we go. Now,
All right.
number 1,
Yes.
I changed the order
So
right
do
away.
I like to have my
I want it
X's
always in
first.
standard form. And then,
All over.
yep, we'll rewrite
X
that.
squared minus 2x minus 8.
So
Okay.
notice the top. It's a binomial. It's not a trinomial.
Right.
And whenever we factor, which we forgot to remind you of, you always ask the question before you start factoring, is there a greatest common factor? So let's look at our numerator. What do they both have in common? They both have a,
X.
but because we started
Since
with
there's
a
a
negative,
negative, we
you
gotta
have
take
to
it out.
factor out a negative x.
All right.
Okay, and what's left
So
over then
we'll
is
put the
x,
negative.
not negative.
Oh, that's
Nope,
right. Because
that's
the
why we
square.
did it. So it'd be x minus 4.
Right.
When you take out a negative, both the signs changed.
Right.
That x changed to a positive and that changed to a negative.
Okay.
Now on the bottom, it's a trinomial.
Yes.
There's no greatest common factor.
All right.
So we do the 2 sets of parentheses.
So what two numbers multiply to get -8, but add to get -2?
Right.
4 and negative. No, -4.
Negative 4 and
Positive 2.
2.
Yep. There we
And an
go.
x and an x. Let's check to make sure that looks right. Yep.
And one little hint
Oh,
here.
yeah.
If you have one on top, it should be on the bottom.
You know what?
too.
That is a great
Since we're
idea, Miss
factoring.
Boyd. Yes.
And we're
Miss,
simplifying.
but always check to make
Yeah,
sure
check
because
to
that's
make sure.
not always going to be the case.
All right, so we get -x over x
Plus 2.
2.
That is your answer.
But now we have to go back to here to
Yep.
see what our zeros can't be. So
X
x
cannot
cannot
be
be
4
positive 4
Or negative 2. Because if they are, your denominator is 0.
Got it. Great.
Multiply. So we have an example 6 and example 7. I'm just quickly seeing what we have left here.
Okay.
And, ooh, we have a lot of stuff. Okay, but that's okay. Because this is good to do in class. Let's just start with this one. When it says multiply, thank you, Miss Boyd. Good job on that. So guess what we have to do?
Foil.
Actually, stop.
Stopping.
Because guess what?
Oh, we can factor
Let's
stuff out.
factor.
Let's do that
Always
first. That's
never
right.
ever multiply until you factor every part you possibly can.
Okay, so this is factored.
Yep.
We're good. X minus 3.
Mhm.
But
But on
this
the
one,
bottom-
we can take a 4 out.
And you take a 4 out, you get
X
x plus 5 times,
times
x plus 5.
is factored.
And you have a binomial.
Ooh, this one's a good one.
That's a perfect square
X,
binomial.
Yes.
So as
plus
always going to be x
3,
plus 3, x minus 3. Because you're looking to see what two numbers multiply to -9
but
and add to
back
0. Look at what we can do, Miss Boyd.
This cancels with this.
Yes, and
this
even though they're
cancels with
crisscrossed,
this.
it's okay.
Right, because we're multiplying.
It's not a proportion. There's not an
Right.
equal sign. So if there's something on top, it can cancel with something
Right.
on the bottom.
So that's all gone.
So
we're left with
1 over 4, and then in
4
parentheses,
times
x plus 3.
plus 3.
Do you see how much easier that
Nice,
was?
that
Do you know
was
what a
way
nightmare we would have
easier.
created,
Yes,
Miss
if we
Boyd?
foiled.
We would have created a
Oh,
cubic,
thanks for
and
stopping
then,
me.
oh man. But guess what?
Now we gotta find our zeros.
Nope.
No.
Look at what it says.
Assume
Multiply.
all-
Assume. So when it
Oh.
says assume that all expressions are defined, you stop. Done.
Great.
Okay? Example 7, and I say we save a 7 and let's jump to 8.
Okay,
There we go.
great. So, like Miss Young said, let's take everything out that we can. So
Yep.
we have an x plus 1 on top.
Mhm.
The bottom we can take out a 3.
Yep.
So we have x plus 2
Very good.
times, here we can take out a 6.
Mhm.
So we're left with x plus 2. And here it's perfect again. Nice. X minus 1, x plus 1.
We like those binomial
do.
squares.
All right, so this one cancels with this one. This one cancels with this one. So
Mhm.
this time we're left with 6 on top
Yep.
over 3 times x minus 1. We can
However,
reduce that.
6 divided by 3 is,
2
and the 2 goes in the
over
top.
x minus 1.
And the reason the 2 goes in the top is you're in a sense dividing both numbers by
Mhm.
3. So 6 divided by 3 is 2, 3 divided by 3 is 1.
And it just goes
Right?
away.
And again, assume all expressions are defined.
Great, so we're done.
There's not an example 9. I'm guessing video questions. So we might have to
Yep,
scroll a
we'll
minute.
scroll.
So simplify. Identify any x values for which the expression is undefined.
Okay.
So there's the problem, and then I'm
Yeah.
going to scroll down.
Those are your possible
There are
answers.
your
Pause it if you need
so
to.
what I would probably do is hit stop right here, and you know what I'm going to do? Scroll down a little bit. See there.
Yeah,
Now you have
got
the
it all.
original, and then
Mhm.
you can hit stop, and then on number 2 it
Says
says
multiply.
scroll
Assume
down.
all expressions are defined.
Yep. So you're multiplying.
Great.
There you go again.
Ooh, now you got
Now,
it all in.
now I got it all in. So there you
Great.
go. I would pause it like right here.
Okay.
See you tomorrow.